Okay. Unit 7, it's about conic sections, and the idea is that, and you will see this picture multiple times, is that you take two cones, attach them to each of their, they're called the vertices, or their tops there. And you can take a two-dimensional shape, a sheet of paper, and make a cross-section. And depending on how that piece of paper goes into your cone or conic, you get a different graph. And the first one we're going to talk about here is a circle. So the reason why we're going to talk about a circle is it is something you did do in geometry before. You might not remember it, but it's something you have done. But let's start off with the equation of a standard circle. You do have x squared and y squared. So you got x minus h squared, y minus k squared equals r squared, where h and k are the center of your circle, and r is your radius. Okay, here if I just had x squared plus y squared equals r squared, that means that my center was my origin. Now, how do you figure out where the center is? We'll talk about that, but it's usually if you can kind of recognize what the radius is, you can kind of get an idea of ballpark where the middle of that is. So if we were to graph a circle, okay, again, the parentheses are kind of gone away for x and y, so there's nothing really put in there. And what we are going to do is have an origin as our center. So 0, 0 would be the center right there. Now careful, I'm never going to ask you to graph 36, so take the square root of that. Since it's r squared, to get r, you'll square root that, and that is 6. So what I'm going to do is go up 6 blocks from there. 1, 2, 3, 4, 5, and 6. I'm going to go down 6, to the right 6, and to the left 6, and that's enough for me. Connect those dots as best as you possibly can in kind of a circular shape. See, I missed that one too. But there's the idea. That's the general idea of what I'm looking for the graph of a circle. Okay. I have x minus h, so h is positive 2. Y minus k, so I'm going to make that as y minus a negative 1. So negative 1 is the other part of my center. So I'll go to 2, negative 1 right there. And 16, take the square root of that and get 4. And again, I'm going to count over 1, 2, 3, 4 from the center. Up 4 from the center. Down 4 from the center, and to the right 4 from the center. So about right there. And I'm just going to go and I'm going to connect those dots. Again, I am not at all good at drawing these circles, so that is good enough for me. But how does this compare to x squared plus y squared is equal to 1? So you could call this the unit circle. It really is moved to the right 2 units, and it's gone down 1. And it's grown by a multiple 4, really, because you took that radius of 1 and changed it to a radius of 4. Okay, so how would I get that information from the graph? So there we go. See how there's this uniform distance of 3 from that origin. So my origin is my center, 0, 0. And my radius would be 3. You have x minus 0 squared, but we're going to simplify that into x squared. Plus y minus 0 squared, but we're going to simplify that into y squared. And don't forget to take that 3 and square that also, so that becomes 9. So that'd be the equation of that particular circle. Okay, write the equation of circle with a center of negative 1, 2, 3, excuse me. So that's your h and your k, there's your radius. So again, that's x minus the negative 1 squared plus y minus 3 squared equals 7 squared. So you usually clean that up to make it plus 1. Minus 3 squared equals 49. So there's the equation of the circle off of that given information. And then finally, here we go. What if I knew that the center was here, but it's just going to pass through this point, and I don't necessarily know the radius? So what I like to do is give myself a little rough sketch of some graph paper. I know that this point here, I'll go with a different color since that's my graph paper there. I know the center is right there, and I know this point right there, 1, 4, is one of the points on that circle. Well, that distance right there is my radius. And I could think of it as h and k both being 0, x and y being that 1 and 4, and I could just go to my formula, x minus h squared, y minus k squared, and just plug in all that information. So 1 minus 0 squared, let's see, my y was 4 minus 0 squared equals r squared, and it's 1 squared plus 4 squared equals r squared, so 1 plus 16 radius is the square root of 17. So the equation then would be x squared plus y squared. Remember the origin was 0, 0. That's my center, is equal to the square root of 17 squared, or x squared plus y squared is equal to 17. Okay, same idea. I could graph those, kind of give myself an idea. But again, that's my h, that's my k, there's x, there's y. So my x minus h squared, my y minus my k squared. So 4 squared plus, remember that's going to be plus 6, so that's 16 plus 36. 2, 1, 52. The square root of 52 is my radius, but when I plug that back into my equation, I'm going to end up squaring it again. So I've got x minus 2 to the second power plus y minus a negative 3, so plus 3 squared equals the square root of 52 squared, or what will turn into just 52. And that's the equation of my circle. So there you go. These are not functions. In terms of domain and range, we're not going to really attack that so much anymore. The reason why it's not a function is because if I were to do the vertical line test, these things don't pass. So you can come up with an equation to write for a circle, but you can't come up with a function.